Good day, everyone. Today we'll be talking about division in modular arithmetic. Okay, so we have an example here. Evaluate the following. You can see them. So we are going to solve A to C. It's going to be a little bit, long video, but do well to, watch and then learn. Okay. So let's begin with the first one, where we have 3 divided by 3, okay, in mode 6. Okay, so one of the easiest method I derive for solving division in modular arithmetic is the tabular method. The reason why I love using the tabular method, especially for those of us who are still in secondary school level, is that it's going to bring out all the what values of x, or all the answers, to the problem. Because sometimes you might have more than one answer when you resolve problems in modular arithmetic. Is that okay? So that's the main reason why I love using the tabular method. All right. So doing that now, you're going to say let 3 divided by 3, be equals to a particular variable, say x, and then 3 divided by 3 is the same thing as 3 over 3 equals to x is the same thing as x over 1. Okay, cross multiplying now, you have 3 times x, 3x equals to 3 times 1 is 3. Is that okay? Then you quickly draw your table. You draw a table like this. All right. So the table is going to contain x, and then your 3x that you have there. Don't forget this is in mode, 6. So here you have x ranging from 0, 1, 2, 3, 4, and 5. Since we are dealing with mode 6, the values of x should not exceed 5. Okay, so now 3x simply means 3 multiplied by x, and then your x values are already there. So what you do now is use them to multiply 3. Don't forget we are doing that in mode 6. So if you have anything equal to 6 or greater than 6, we have to reduce and then pick the remainder. Is that okay? So 3 times 0 is just 0. 3 times 1 is 3. 3 times 2 is supposed to be 6, but since we are dealing with mode 6, it's going to be 0, okay? Because 6 divided by 6 is 1, remainder 0. Then 3 times 3 is supposed to be 9, but since we are dealing in mode 6, we are going to have 3. Is that okay? Because 6 into 9 is 1, remainder 3. And then 3 times 4 is 12 normally, but this is going to be 0 because 6 into 12 is 2, remainder 0. And then 3 times 5 is 15 normally, but 6 into 15 is going to give you 2, remainder 3. Is that okay now? So from here, to find the values of x now, you see that x simply means the place where 3x equals 3. And if you look at the row where we have 3x equals 3, if you trace it up to the x values, you see that the fourth 3 correspond to 1. The second 3 on the row for 3x correspond to 3. And then the third 3 correspond to 5. Therefore, x equals 1, 3, and 5. Is that okay? And 5. So that becomes the values of x, okay, for the first problem. Let's quickly look at the b in the same way. All right. So the b, what we have in our question is 2 divided by 3 mode 4. So we have 2 divided by 3 mode 4, okay? So 2 divided by 3, okay? 2 divided by 3. So this is going to be like 2, you say, sorry, first of all say let 2 divided by 3 be equals to a particular variable, say y. So this is just the same thing as 2 over 3 equals to y over 1. Okay, cross multiplying now, this is going to be 3y equals 2, okay, in mode 4. Is that okay now? So what we do here now, we quickly draw our table again. This time the table contains y and 3y. All right. And then since we are dealing with mode 4, the y values ranges from 0, 1, 2, and 3. Is that okay? So now let's multiply now, because 3y simply means 3 multiplied by the y values. So 3 times 0, because the first y value is 0. 3 times 0 is 0. 3 times 1 is 3. And then 3 times 2 is 6 normally, but since we are dealing in mode 4, it's going to be 2. Okay, because 4 into 6 is 1, remainder 2. And then 3 times 3 is 9 normally. So 4 into 9 is, I think, 2, remainder 1. Is that okay? So you have this. So from here, how do we find the y values now? From the table now, you see that 3y is equals to 2 in mode 4 normally. So let's trace now. 3y equals to 2 corresponds to y equals to 2. Is that okay? I think that's the only value for this particular problem. So that means, therefore, you see that, therefore, y equals 2. Is that okay? Y equals 2. So that becomes, the solution to that. Okay, that becomes the solution, because whatever thing you have for y is the same thing for 2 divided by 3, which you are looking for. Is that okay? Same thing with the first problem I solved. Whatever thing you have for x is the same thing as 3 divided by 3. Things is equals to x. Okay, so that is that about that. Let's quickly run through the c. All right, where we have 3 divided by 2 this time around. 3 divided by 2, but still in mode 4. Okay, so you say let 3 divided by 2 be equals to, let's say, x, a particular variable. And then, of course, this is now 3 divided by 2 now equals x over 1. Is that okay? Cross multiplying now, you have 2x equals 3 in mode 4. Is that okay? So you quickly draw your table like this. This time your table contains x and 2x. Is that okay? So x ranges from 0, 1, 2, and 3 because we are dealing with mode 4. All right. So 2 times 0 is 0. 2 times 1 is 2 in mode 4. 2 times 2 is 0 in mode 4, because 2 times 2 is 4 normally. 4 into 4 is 1 remainder 0. Then 2 times 3 is 6, but it's going to be 2 since we are dealing with mode 4. Then check where 2x now equals 3. Okay. If you look at it very well, I don't think 2x has any value now that corresponds to 3 now. Therefore, x, you can say therefore 3, okay, divided by 2 has no solution. Okay, has no solution. That's how you conclude when you have this kind of situation. Okay, where 2x here, for instance, does not correspond to 3 on the table. And that's why I love using the tabular method, because it brings out all these things. Is that okay? So that is basically how to divide in modular arithmetic. Is that okay? So do well to always subscribe, comment, and like for more videos. Thank you.